When an atom gains or loses electrons, does it always get bigger or smaller? The answer might surprise you. Some ions end up much smaller than their atoms, while others become much larger. So what actually controls the size of an ion? In this video, you'll learn how electron configuration affects ionic size. We'll see why cations shrink, why anions expand, and how to compare isoelectronic species. Atomic size depends on two main factors: how strongly the nucleus pulls on electrons, and how much the electrons repel each other. When an atom loses electrons to form a cation, the same nuclear charge is now acting on fewer electrons. With less electron-electron repulsion and the same nuclear pull, the remaining electrons move closer to the nucleus. That's why cations are smaller than their neutral atoms. For example, when aluminum loses 3 valence electrons, it loses an entire electron shell. This forms an aluminum cation with the formula Al3+, and causes a dramatic decrease in radius. On the other hand, forming an anion means gaining electrons. Adding electrons increases electron-electron repulsion, while the nuclear charge stays the same. As a result, anions are always larger than their neutral atoms. When sulfur gains 2 electrons, it forms a sulfide anion with the formula S2-. The added electron repulsion causes the ionic radius to increase significantly. So far, we've seen that losing electrons makes ions smaller, while gaining electrons makes ions larger. Want to turn those milestones into mastery? Tap the link to access the practice test, flashcards, and study guide. Then jump right back into the video. Lock in what you learned and keep going. Now, let's look at isoelectronic species, atoms or ions that have the same number of electrons. Take the following set of species as an example: neutral neon atom or Ne, sodium cation or Na+, magnesium cation or Mg2+, and aluminum cation or Al3+. They all share the same electron configuration, so electron-electron repulsion is the same. Because the number of electrons stay constant, size depends on nuclear charge. More protons mean a stronger pull. Among isoelectronic species, ionic radius decreases as atomic number increases. For example, oxide anion or O2- and fluoride or anion F- are isoelectronic. But fluorine has more protons, so the fluoride anion is smaller. A common mistake is assuming equal electrons means equal size. Nuclear charge still matters. To recap, cations are smaller, anions are larger, and for isoelectronic species, more protons mean a smaller radius. Ready to quiz yourself with the content covered in this video? Check out the link in the description, where you'll find Quizlet content made just for you.